So in the topic of variation, we are going to see today some numericals. In the question number 1, it is given that P is equal to 32 and Q is equal to 4. Express P in terms of Q if P varies directly as Q to the power 3. So this can be written as P is directly proportional to Q to the power of 3, or P is equal to K to the power of Q to the power of 3. So first and foremost, we require to find out the value of K. K is equal to P divided by Q to the power 3. Therefore, you can write K is equal to P. P is given 32. Q is equal to 4. So 4 to the power of 3, which can be written as equal to 32 divided by 64. 4 to the power 3 is 64. 4 for the 16, 16 for the 64. 32 ones are 32, 32 twos are 64. Therefore, you can write K is equal to 1 divided by 2. Further, you can write now the equation which is given over here, P which is equal to K, K is 1 by 2, Q to the power 3. So you have the required relation which is given as P is equal to 1 by 2 Q to the power 3. You can also follow the same thing in the next slide, in which I have given in terms of the automation. Now let us try to see the second part. In the second part, it is given by P varies directly as square root of Q. P varies directly as square root of Q. So P is directly proportional to square root of Q. In this case, you can write P will be equal to some constant K into square root of Q. Again, we have to find the value of K the second time. First time K and the second time K will not be remaining same. So K is equal to P divided by square root of Q. Therefore, I can write K is equal to P. P is nothing but 32. 32 divided by square root of Q is equal to 4. So square root of Q is equal to 4. So this can be written as equal to 32 divided by 2, which is nothing but equal to 16. Therefore, our final equation becomes P, which is equal to K times square root of Q, will be equal to K is 16 times square root of Q. So this is our equation which is required. So let us go to the next slide. Here is answers given in the proper formats. The next question given over here is a word question or a word problem which most of the students find it difficult. An object falls from a height h meter, varies directly as a square of time. in time t seconds on certain planet Q. So object is falling at a height h meters and it is directly proportional to the square, not square root. Most of the children are having a problem about square and square root, which I've seen in my normal classes. So it's a square of its time t in seconds. And object falls at a height h equal to 5 meter in 2 seconds. So by seeing this statement over here, you can write height h is directly proportional to the square of the time. Square of the time, so h is directly proportional to t square, or h will be equal to some constant k times t square. You might be thinking why I'm taking every time k. You can put c, you can put any other alphabet, but normally it is k itself. So k can be written as equal to h divided by t square. So now is a turn to find out the value of k. So we find the value of k. K becomes equal to h. H is given equal to 5. And time t is given in seconds. 2 square. 2 square is equal to 4. And so k is equal to 5 by 4. Put the value of k over here. You get h is equal to k. K is equal to 5 divided by 4 times t square. Times t square. Now the second part of the question, they are given calculate the time taken in seconds for the objects to fall from a height of 45 meters on the planet. So we have to find the time t. So h is given 45. So put h equal to 45. Again, certain students, they put this 5 over here. That is not the right thing. It is this 45 you have to put. The constant is not going to change. 5 by 4 multiplied by t square. T square now is not known, not this t square. So rearrange it, you get the value of t square becomes equal to 45 times 4 divided by 5. 5 nines are 45. So t square becomes equal to 4 into 9, 36, or time t becomes equal to 36 seconds. Root of 36, that t becomes equal to 6 seconds. So let us see this same thing in terms of the particular part given in the next slide. So h is proportional to t square, h is equal to kt square, k is equal to h by t square. You find the value of k and write the final equation for the height h in terms of t square. Substitute the given values of h, you can get the value of t.